This is a brief introduction to solutions. In a solution, you have two things that are dissolved together. The solute is what is dissolved. The solvent is what does the dissolving. Most of the time we use water as our solvent. Solvation is when that solvent surrounds the solute and dissolves it, and I'll show you a picture in just a minute. Hydration is when you have water that chemically reacts with an ion or a substance, and a good example of this is copper 2 sulfate actually will bond to water and have it surrounding the solid. These typically are very colorful compounds, and you actually can heat them up and drive the water away, evaporate the water away, and have it break free from the copper 2 sulfate and have just plain copper 2 sulfate anhydrate is what it's called. It means without water. But copper 2 sulfate does attract water, and typically there are 5 waters surrounding it. There's a picture of it. How something dissolves or solvation. You have the water pulling the ions apart. You can see how the water surrounds the solid, and then water has positive and negative areas. There's negative areas around the oxygen and positive areas around the hydrogen. And so you can see how it orients itself around the ions. If it's a cation like this sodium, you can see those negative water molecules closest to them. They're attracted to it, and they're going to cause the sodium chloride crystal to break apart. And the opposite over here, you have the positive ends of those hydrogens surrounding the negative chlorine anion, and it will pull it apart from the sodium. Here's a picture. The water molecules are really, really tiny, and then the ions are larger. Molarity is a solution concentration unit, and we figured out by taking the moles of the solute and divided by the volume of the solution in liters. So you first take the mass of your powder that you're using, and you will have to do a quick math conversion and change grams to moles. Then you'll add it to your vessel, and then you'll add the water on top of it, because this is volume of solution, not amount of water, but volume of solution that we divide it by. Let's go ahead and do some molarity problems. So again, molarity by definition is moles per liter. And I already have moles, 4.53 moles of lithium nitrate, and my total solution is 2.85 liters. So the units are moles per liter, and it's also the formula. So dividing, I get 1.59 big M, and it's lithium nitrate. In this next one, we're working a little bit backwards. So we do know our formula. Molarity is moles per liter, but it says how many grams are needed to make 5,000 cubic centimeters of this molar solution. What I'm going to do is I'm going to solve for moles first. And to find moles, I'm going to take molarity times the liters. So my molarity is 0.133. And my liters that I have, well, I'm going to have to do a little bit of calculation here. So this is actually milliliters, because 1 cubic centimeter is equal to 1 milliliter, and I have 5,000 milliliters. So how many liters that is, I move my decimal over 3, I have 5 liters. Remember that the formula for molarity is moles per liter, so I can actually change this guy to moles per liter. And so liters is going to cancel. I'm going to be left with moles, and I will be left with 0.665 moles. And then I need to convert these moles to grams. So adding up 1 Mn, 1 Se, and 4 oxygens, I get 151 grams is equal to 1 mole. So I just multiply, and I'm going to need 100.4 grams of the magnesium sulfate. And so I'll take my vessel and I'll add that. And then I will fill it up to the 5 liter mark. So that's going to be quite a lot of this solution. Dilutions, this is when you use this formula. You start off with the same amount of moles of the substance that's dissolved. And so all you're doing is adding more water. And so you can use this formula. Molarity times volume equals molarity times volume. And let's do a problem. What volume of water would you need to add to a 12 molar hydrochloric acid solution to make a 500 milliliter of a 3 molar solution? So let's do this problem. So I'm just going to line things up. So 12 molar, and we don't know the volume. And on this side, I have 3 molar and 500 milliliters. You don't have to be in liters for this one. And then doing my math, 3 times 500 divided by 12, and I get my volume that I need of the 12 molar to make the dilution is 125 milliliters. So I'm going to take a container and I'm going to put 125 milliliters in it, and then I'm going to fill it up to the 500 milliliter line.